So in this video, we're just going to briefly explain what cofactor and adjoint matrices are. So remember, in a previous video, we talked about the cofactors for a matrix A. And in general, what we said was that the cofactor for a matrix, a cofactor, there's more than one cofactor for a matrix, but a cofactor for the ith row and jth column is the number that you get when you multiply -1 raised to the I plus jth power times the determinant of the minor matrix for row I, column j. And so what we want to remember is how we calculated the minor matrix. And the minor matrix was simply we struck out row I, column j, and we constructed a matrix from the entries that were remaining. So for example, if we had a simple 3 by 3 matrix, say it has 1, 2, 3, 1, -2, 5, 1, 2, 2. So if we wanted the cofactor for row 2, column 3, so C sub 2, 3, then we would simply take -1 and raise it to the 2 plus 3 power, so the 5th power, and then we would multiply it by the determinant of the minor matrix for row 2, column 3. And the minor matrix we get by striking out row 2 and column 3 and constructing the matrix from the remaining entries. So we have 1, 3, 1, 5, 1, 3, 1, 5, and then we would just work this calculation through. And so all the cofactor matrix is a matrix that contains all of the cofactors for a matrix A. So you have the cofactor number for row 1, column 1, row 1, column 2. You fill out the entire matrix all the way through row n, column n. You put the cofactors in, and this is simply the cofactor matrix. And the cofactor matrix is going to be useful in terms of defining a formula for inverses of matrices. So it's going to be more of theoretical value than it is going to be of computational practical value. So if I call this matrix C, the cofactor matrix, if I call it capital C, all the adjoint matrix is for a matrix A is you transpose the cofactor matrix, and that's the adjoint matrix for a matrix A. So in the next video, we'll go through and construct a cofactor matrix and an adjoint matrix.